Sum of first and natural numbers. Okay, so let's say we have the natural numbers 1, 2, 3, 4, and so on, and the last term is denoted by n. We want to find out the sum of these for n natural numbers. So we're going to suppose that Sn represents the sum up to the n terms. So here we will get an arithmetic series 1 plus 2 plus 3 plus 4 all the way up to the last term, that is n. Now what we will do, we're going to consider the same term, but we are going to reverse the numbers. That means we're going to consider the first term as n, followed by the second last term of Sn, which is n minus 1, but we'll consider it to be the second term. Then we have n minus 2, followed by n minus 3, so on. And the last term is going to be equals to 1. Now let's do one thing. Let's add the two sums. On the left hand side, we have 2 times Sn. Now we're going to add the consecutive terms. So that means if we take the first term, which is 1, and add it to our n, this is going to give us n plus 1. Add it to, now we have 2 added to n minus 1, so that's going to give us n plus 1. Next, we add up the consecutive third term, so we have 3 added to n minus 2, so that gives us n plus 1. Then 4 added to n minus 3, that's n plus 1. So this keeps on going, and the last term, that becomes n plus 1. So we now have 2 times Sn. This is going to be equals to, now how many terms are present here? So here in this particular sum, there are n terms that's present here, because if I understand this, if we consider this Sn, which is the sum of n natural numbers, sum of natural numbers up to n, so here we have n number of terms, and we are again adding it to the same sum Sn, so that also has got n number of terms. So upon addition, we must get n number of terms, which means that n plus 1, that's repeating n number of terms. So Sn comes out to be equals to n multiplied to n plus 1 divided by 2. So this is going to be the sum to n terms of n natural numbers, the first n natural numbers. That's very important. However, there is one more way. We know that 1, 2, 3, 4, this is an arithmetic sequence. That means the terms are going to be in arithmetic progression. So here, the sum up to n terms, we have a standard formula for it. It's given by n over 2 multiplied to 2 times a plus n minus 1 times the common difference d. Now since it's an arithmetic progression, so we have n over 2 multiplied to, what is the first term here? The first term here, that's 1. So we have 2 times 1, that gives us simply 2. Add it to n minus 1 times the common difference d. The common difference, that's equals to 1. So when we simplify this, we get n multiplied to n plus 1 divided by 2. So this is another way of finding out the sum of the first n natural numbers. Next, we will try to figure out what is the sum of the squares of first n natural numbers. So we consider the first n natural numbers. We have 1, 2, 3, 4, all the way up to the last term, which is n. We're going to square each of the term. That gives us 1 squared, 2 squared, 3 squared, 4 squared, n squared. Now, we're going to take the sum. If we take the sum, we have 1 squared plus 2 squared plus 3 squared plus 4 squared, all the way up to the last term, which is n squared. So this is going to be the sum of the squares of first n natural numbers, and we have to find out its value. So what we'll do, we will suppose that let Sn represent the sum of the squares of first n natural numbers. So let's keep it aside for the time being. So in order to find out the sum, we have to take the help of an identity. So here the identity that we will be using is, we know that, let's say if we take x plus 1 whole cube, and from here subtract x cube, then this is going to give us 3x squared plus 3x plus 1. Now this is a very important identity. We have to remember this identity in order to find out the sum. Okay, so here what we'll do, we're going to consider different values of x. So let's start with x equals to 1. So when we have x equals to 1, we'll substitute this on the both sides for x. So we have 1 plus 1 whole cube, so that's simply 2 cube. So we have 2 cube minus 1 cube. This is going to be equals to 3 times 1 squared plus 3 times 1 plus 1. We're not going to simplify on any of the terms here. We're going to keep it as it is. That we come to x equals to 2. That means we have 2 plus 1, so that's 3. We have 3 raised to the power of 3. minus x cubed, so that's 2 cubed. This will be equals to 3 times 2 squared added to 3 times 2 added to 1. Next we have x equals to 3. So that's going to give us 4 cubed minus 3 cubed. This will be equals to 3 times 3 squared added to 3 times 3 plus 1. So we can continue this. So next what we'll do, we'll consider x to be equals to n minus 1. So when we choose x to be equals to n minus 1, so n minus 1 added to 1, so that gives us simply n cubed. Minus, we have n minus 1 whole cube. This will be equals to 3 times n minus 1 whole squared added to 3 times n minus 1 plus x. Now we're going to consider x to be equals to n. That means we now have n plus 1 whole cube minus n cube. This is going to be equals to 3 times n squared plus 3n added to 1. Okay, now what we'll do, we're going to find out the sum. We're going to sum each of the terms on both the left hand side and the right hand side. Now here, immediately we observed that 2 cube, negative 2 cube, 3 cube, negative 3 cube, similarly 4 cube, all of this will get cancelled out. We have n cube, negative n cube cancelling out. Also we have negative n minus 1 whole cube, this is getting cancelled out, which means that on the left hand side we will be left with this term n plus 1 whole cube. And we have negative 1 cube remaining. That will be now equals to, now let's see one thing. So if we add the first term of each of the expression on the right hand side, so here we see that 3 is a common factor. So we're going to take 3 as the common factor. So 3 gets multiplied to 1 squared plus 2 squared plus 3 squared plus all the way up to n squared. Then we are going to add the second term of each of the expression, again where we can take 3 as the common factor. So we have 3 multiplied to 1 plus 2 plus 3 plus all the way up to the last term, that is n. And then we have 1 plus 1 all the way up to n number of terms. So there will be total n number of terms of 1 that are getting added. Okay, let's try to simplify this. So we now have n plus 1 whole cube minus 1 equals to 3 times. So this is the sum that we are trying to find out. This is Sn, that is the sum of the squares of first n natural numbers added to 3 times. Now this is the sum of n natural numbers. We've already found out that this is simply n times n plus 1 whole divided by 2 added to. Now we have 1 is getting added to itself n number of times. So we can say this is simply 1 multiplied to n, or we can say it's n. Okay, since we want to find out Sn, we're going to rewrite everything. So we have 3 Sn, this is going to be equals to, we have n plus 1 whole cube minus 3n times n plus 1 divided by 2. Then we have negative n minus 1. Okay, so we are going to further simplify. Now let's consider the second, third and the fourth term. So here if we take negative as the common factor, this is going to become n plus 1. Now the reason why we took negative as the common factor, because in each of the 3 terms we can pull out n plus 1. So we have now n plus 1 as the common factor. So this is going to get multiplied to n plus 1 whole squared from the first term minus 3n over 2. That will be the second term minus 1. Okay, further simplification is going to give us n plus 1. So this is going to get multiplied to n squared plus 2n plus 1 minus 3n over 2 minus 1. So here we can cancel out 1 and negative 1. That will be equals to n plus 1 multiplied to, so here we have n squared and then we have 2n minus 3n over 2. So that's going to give us positive n over 2. Okay, so we have n plus 1. Now from n squared plus n over 2 we can pull out n. So we have n times n plus 1 multiplied to n plus 1 half. This will be 3. This will be equals to n times n plus 1 multiplied to 2n plus 1 whole divided by 2. And on the left hand side we had 3Sn, but we need Sn. So therefore we're going to divide both sides with 3 to get Sn equals to n times n plus 1 times 2n plus 1 whole divided by 6. So this is the sum of the squares of the first natural numbers, or we can say 1 squared plus 2 squared plus 3 squared, all the way up to the last term, n squared. This sum of the squares, that's going to be n multiplied to n plus 1 times 2n plus 1 whole divided by 6. This is our sum. Okay, so next we will move on to the sum of the cubes of first n natural numbers. So to find out the sum of the cubes of the first n natural number, that means we'll first assume Sn represents the sum up to the first n natural numbers, the cube of the first n natural numbers. That means we have 1 cube plus 2 cube plus 3 cube all the way up to the last term, which is n, and we're going to cube that value. Now, what we'll do, we are going to use the same identity. So we have the identity, so we are going to use x added to 1 raised to the power of 4 minus x raised to the power of 4. And when we expand it, then is it going to give us 4 times x cubed added to 6x squared plus 4x plus 1. We're going to use this particular identity. We'll start with x equals to 1. So that's going to give us, so 1 plus 1, that means 2 raised to the power of 4 minus 1 raised to the power of 4. This will be equals to 4 times 1 cubed added to 6 times 1 squared plus 4 times 1 plus 1. X equals to 2. So that's going to give us 2 plus 1, so that's 3. We have 3 raised to the power of 4 minus 2 raised to the power of 4. That will be equals to 4 times 2 raised to the power of 3 plus 6 times 2 raised to the power of 2 plus 4 times 2 added to 1. Let's take x equals to 3. So we have 4 raised to the power of 4 minus 3 raised to the power of 4 equals to 4 times 3 raised to the power of 3 added to 6 times 3 squared added to 4 times 3 plus 1. So we are going to continue up to x, we'll consider x to be equal to n minus 1. So here we will get n raised to the power of 4 minus n minus 1 raised to the power of 4. This is going to be equals to 4 times n minus 1 whole cube added to 6 times n minus 1 raised squared plus 4 times n minus 1 plus 1. Then finally we will choose x to be equals to n, such that we have n plus 1 raised to the power of 4 minus n raised to the power of 4. This is going to be equals to 4 times n cubed plus 6 times n squared plus 4 times n plus 1. Now we're going to add them. So on the left hand side we have 1 raised to 2 raised to the power of 4 and negative 2 raised to the power of 4 cancelling out, 3 raised to the power of 4, 4 raised to the power of 4, n raised to the power of 4, negative n minus 1 raised to the power of, all of them gets cancelled out. That leaves us with n plus 1 raised to the power of 4 minus 1 raised to the power of 4 on the left hand side. And on the right hand side we have 4 multiplied to 1 cubed plus 2 cubed plus 3 cubed to up to n cubed. Then we have plus 6 multiplied to 1 squared plus 2 squared all the way up to n squared. Then we have 4 multiplied to 1 plus 2 all the way up to n. And then we have 1 plus 1 all the way up to n number of terms. So here, let's further simplify. On the left hand side, we have n plus 1 raised to the power of 4 minus 1 equals to 4 times. So this is the sum that we need to find out. So we have 4 times Sn added to 6 times. Now 1 squared plus 2 squared, just now we found out its sum. So that's n multiplied to n plus 1 times 2n plus 1 whole divided by 6 plus 4 times n plus 1 divided by 2 added to the 1 getting added to itself n number of times. So this simply equals to n. Okay, so here we can factor out 6. 2 times 2, that's 4. So now we have n plus 1 raised to the power of 4 minus 1 equals to 4 times Sn added to n times n plus 1 times 2n plus 1 added to 2n times n plus 1 plus n. Okay, since we need Sn, so we're going to rewrite all the terms where 4 times Sn equals to n plus 1 raised to the power of 4. Then we have negative n times n plus 1 times 2n plus 1 plus 2 times n plus 1. Then we have, this is going to be actually negative minus n plus 1. Okay, now we have 4 times Sn equals to n plus 1. We're taking it as the common factor from all the 4 terms. So that leaves us with n plus 1 whole cubed minus n times 2n plus 1 minus 2n minus 1. Okay, so we have 4 times Sn equals to n plus 1. So let's expand n plus 1 whole cube. So that's going to give us n cube plus 3n squared plus 3n plus 1 minus 2n squared minus n. Then we have negative 2n minus 1. So positive 1 and negative 1 gets factored out. We have negative n, negative 2n, and positive 3n factoring out. So this is going to leave us with 4 times Sn equals to, we have n plus 1 multiplied to, we have n cubed. So 3n squared minus 2n squared, that's positive n squared. Okay, so further simplification is now going to give us 4 times Sn equals to, so we're going to pull out n squared. So we have n squared times n plus 1. So this is also going to be n plus 1, so we are going to square this value. So Sn comes out to be equals to n times n plus 1 divided by 2 whole squared. So this is going to be the sum of the cubes of first n natural numbers. So here I have listed out all the 3 formulas. So first, if we take the sum of the first n natural numbers, that comes out to be n times n plus 1 over 2. For instance, let's say we want to find out the sum of the first 10 natural numbers. That means when n corresponds to 10. Then in that case, the sum of the first 10 natural numbers is simply 10 multiplied to 10 plus 1 divided by 2. So this was going to be 10 times 11 over 2, which gives us, so 2 times 5, that's 5 times 11, that's 55. So that means if we take the sum of the first 10 natural numbers, the sum is going to be equals to 55. Then we have the sum of the squares of the first n natural numbers. So here let's say we take n to be equals to 10. Then we have 10 multiplied to 10 plus 1, that's 11, multiplied to 2 times 10, that's 20, 20 added to 1, that's 21, divided by 6. So 6 can be also written as 2 times 3. So we have 2 times 5, that's 10, 3 times 7, that's 21. So we have 7 times 11, that's 77. So 77 times 5 equals, that will become equals to 385. Then we have finally the formula for the sum of the cubes of the first n natural number. So here, if we take n equals to 10, so here we can observe here that this is n plus 1 over 2. We've already found that's 55. So what we'll have? We'll have square of 55. So that's going to give us 3025.